This is Euclid Book 6, proposition number 17, and it says, if three straight lines be proportional, the rectangle contained by the extremes is equal to the square on the mean. And if the rectangle contained by the extremes be equal to the square on the mean, the three straight lines will be proportional. Alright, we're going to have, let the three straight lines A, B, and C be proportional. Okay. We have line A right here. We have line B right here, and we have line C right here. I made A 4 inches long, B 2 inches long, and C 1 inch long. Okay. Let the three straight lines A, B, and C be proportional so that as A is to B, so as B is to C. So as 4 is to 2, as 2 is to 1. Well, 4 divided by 2 is 2, and 2 divided by 1 is 2. So they're proportional. I say that the rectangle contained by AC is equal to the square on B. What is the rectangle contained by AC? Well, these two lines here, this one here, and this one here, are the same length as A. And this line here and this line here, both of these are the same length as C. So the rectangle contained by AC, okay, is equal to the square on B. Well, all four of these lines, this one here, this one here, this one here, and this one here, are equal to the length of B. Alright? So we're going to say that the area contained here is the same area contained here. Okay. Alright, we're going to draw a letter D. See that letter D right there? That's going to be the same size as B. We made B 2 inches long. We're now going to make D 2 inches long. So let D be made equal to B. Then, since as A is to B, so as B is to C, as this is to this, as this is to this, okay, and B is equal to D, which obviously we just said that B is the same length as D, therefore as A is to B, so as D is to C. As A is to B, so as D is to C. But if four straight lines be proportional, the rectangle contained by the extremes is equal to the rectangle contained by the means. This is by Euclid Book 6, proposition number 16, which we just covered. Therefore, the rectangle AC is equal to the rectangle BD. So this is equal to that. But the rectangle BD is the square on B, for B is equal to D. Well, if two of these lines are the length of B and two of these lines are the length of D, and B and D both are the same size, then this is also a square. Therefore, the rectangle contained by AC is equal to the square on B, which we just established. Next, let the rectangle AC be equal to the square on B. We're now going to say that this is equal to this. Okay? I say that as A is to B, so as B is to C. For with the same construction, since the rectangle AC is equal to the square on B, since this is equal to that, this is equal to that, okay? While the square on B is the rectangle BD, for B is equal to D. Okay, so we have two of these sides as B, two of these sides as D, and it doesn't really matter because D is equal to B, so all four of these sides are the same size, in this case 2 inches. Therefore, the rectangle AC is equal to the rectangle BD. I already said this is equal to this. But if the rectangle contained by the extremes be equal to that contained by the means, the four straight lines are proportional. This is by Euclid Book 6, proposition number 16. Therefore, as A is to B, as A is to B, so is D is to C. So is D is to C. But B is equal to D. Therefore, as A is to B, so is B is to C. And that's what we were trying to prove. I will tell you more in the next proof. Stay tuned.